Dr. Marilia Urlaub thought she had made a calibration error. Her underwater sensors off Sicily were showing Mount Etna's flank moving faster than continental drift, not millimeters per year, but centimeters per day. A geological impossibility that violates everything volcanologists understand about how mountains behave. Until she checked the historical records. Hidden in archaeological sites that are 8,000 years old across the eastern Mediterranean, researchers have found the smoking gun. Tsunami deposits in Israel, marine sediment in Cyprus, coral fragments scattered across Lebanon's mountains, all dated to the exact same moment in time. The moment Etna's eastern face collapsed into the sea and sent a liquid mountain racing across 3 countries. Now GPS satellites are detecting the same pre-collapse signature, the same gravitational creep, the same deep fracture patterns that preceded the ancient disaster. But this time, 20 million people live in the impact zone. What happens when a volcano does not just erupt but falls into the ocean? And why will seismologists not give a straight answer about when Etna's slow-motion collapse becomes an unstoppable avalanche? Mount Etna, the largest active volcano in Europe, has been a looming presence over Sicily for millennia. At 3,326 meters tall, this stratovolcano has shaped the landscape and lives of those who reside in its shadow. But while Etna's fiery eruptions have captivated the world's attention, a hidden threat lurks beneath its slopes, a catastrophic collapse that could unleash devastation across the Mediterranean. To fully grasp the magnitude of this threat, we must journey back 8,347 years ago to the ancient village of Atlit Yam, submerged off the coast of Israel. Here, archaeologists made a chilling discovery. The remains of a thriving Neolithic settlement suddenly and violently wiped out. Skeletons were found clutching each other in doorways. Wells were filled with deep-sea sediment. Marine shells were scattered in homes 1,600 kilometers from their origin. What force could cause such instantaneous devastation? The answer lay in the work of geological detectives like Dr. Maria Teresa Pereschi and her team. By carbon dating tsunami deposits found up to 20 kilometers offshore Sicily, they uncovered evidence of a single catastrophic event, the collapse of Etna's eastern flank, which unleashed the equivalent of 10,000 Cheops pyramids into the Mediterranean Sea. But Atlit Yam was not an isolated incident. As researchers delved deeper into the geological and archaeological records, a terrifying pattern emerged. Etna, it seems, operates on a cycle, with collapses occurring roughly every 8,000 years. The evidence is scattered across the Mediterranean. Ancient harbours lie submerged off Tunisia. Neolithic villages are entombed under Crete's beaches, and a trail of destruction stretches from the Bosphorus to the Nile Delta. Professor Enzo Boschi, one of Italy's most respected geophysicists, puts it bluntly. We know from the geological record that volcanoes with gravitational instability have collapsed. It is not a matter of if, but when. Now, as modern science begins to unravel the mysteries of Etna's past, a chilling realization dawns. The clock is ticking on the next catastrophic collapse. Fast forward to 2017, and the warning signs of Etna's impending doom are impossible to ignore. Dr. Marilia Urlaub and her team at the Geomar Helmholtz Center made a startling discovery using cutting-edge underwater sensors. Etna's southeastern flank, a staggering mass of 35 billion tons of volcanic rock, was sliding towards the Ionian Sea at an unprecedented rate of 14 millimeters per year. This was no gradual tectonic creep, but a rapid gravitational failure that defied all geological norms. Using the state-of-the-art GeoC array, Urlaub's team detected sub-centimeter movements deep beneath the Mediterranean, painting a chilling picture of a mountain literally collapsing under its own weight. The implications, as laid out by Professor Heidrun Kopp, are nothing short of apocalyptic. Etna's southeastern flank could collapse catastrophically and trigger a tsunami that would devastate the entire central Mediterranean. Real-time GPS data reveals the flank is moving faster than continental drift, with transponder networks detecting ominous slow slip events, massive displacements without the usual seismic signatures. In just 8 days in 2017, sensors recorded a jaw-dropping 4-centimetre shift, a rate that shatters all previous understanding of volcanic movement. But it is not just the speed of Etna's unravelling that has scientists sounding the alarm. It is the sheer scale of the potential collapse. To put it in perspective, the 1980 eruption of Mount St. Helens, which claimed 57 lives and reshaped the surrounding landscape, involved a mere 2.5 cubic kilometres of rock. Etna's unstable flank is staggering, 1,500 cubic kilometres, enough to fill the entire Grand Canyon and then some. As Dr. Urlaub and her colleagues pore over the data, a grim picture emerges. The same patterns that preceded the Atlit Yam cataclysm 8,000 years ago are now unfolding on an even grander scale. The underwater sensors, GPS data, and geological models all point to one inescapable conclusion. Etna is poised for a collapse that could rewrite the map of the Mediterranean. The worst-case scenario is almost too terrifying to contemplate. Dr. Gianluca Valencese, a senior seismologist at Italy's National Institute of Geophysics and Volcanology, has run the numbers, and the results are nothing short of apocalyptic. The collapse of Etna's flank would unleash the energy equivalent of 2,000 nuclear weapons, detonating simultaneously underwater. Picture a 50-metre tsunami travelling at 800 kilometers per hour, slamming into beats of coastal cities with just minutes of warning. 20 million lives hang in the balance across Sicily, Malta, Italy, Greece, and North Africa. Nuclear facilities, ports, and entire infrastructures sit directly in the crosshairs of this geological doomsday scenario. In the face of such an existential threat, one would expect a global mobilization, a Manhattan Project for the Mediterranean. But instead, an unsettling silence emanates from the corridors of power and the halls of academia. Whispers abound that research teams have been slapped with classification orders, their findings buried deep in the vaults of government secrecy. Mediterranean nations are quietly revising emergency protocols for deep water evacuation, a euphemism for the unthinkable. Tsunami drills, once unheard of in the region, are now suddenly mandatory. The writing is on the wall, but those in positions of authority seem determined to look the other way. The question is, why? What do they know that they are not telling us? But the implications of Etna's collapse extend far beyond the immediate devastation. Like a nightmarish game of dominoes, the collapse could trigger a cascade of catastrophic failures across the Mediterranean. The sheer force of the event could destabilize the precariously balanced Mount Stromboli and Mount Vesuvius and set off a chain reaction of volcanic catastrophes. The delicate ecosystem of the Mediterranean basin, shaped by millennia of sediment deposition, could be irrevocably shattered. Massive underwater landslides, displaced sediment and altered currents would transform the very fabric of marine life, with consequences that are difficult to fathom. And then there is the economic fallout. The simultaneous collapse of tourism, shipping, and energy infrastructure would send shockwaves through global markets, making the 2008 financial crisis look like a minor blip in comparison. The interconnected nature of our world means that no corner of the globe would be spared the aftershocks of Etna's fury. Perhaps the most unsettling aspect of this looming catastrophe is its eerie predictability. Etna's collapse is not some random twist of geological fate, but rather a clockwork, an 8,000-year cycle that has repeated itself with unerring precision. It is as if some ancient doomsday mechanism is etched into the very crust of the Earth, a ticking time bomb that humanity has unwittingly built its civilizations upon. And now, as the sands of time run out, we find ourselves facing questions that strike at the very heart of our understanding of the planet we call home. What triggers this 8,000-year cycle of destruction? Is it truly an immutable force of nature, or are there variables we have not yet accounted for? Could human activity, with its relentless interference in natural systems, be altering the timetable of Etna's collapse in ways we cannot yet foresee? And perhaps most importantly, do the people living in the shadow of this geological time bomb have a right to know the truth about the cataclysmic fate that may await them? Is it ethical for governments and scientists to keep the populace in the dark, or do we have a fundamental right to make informed decisions about the risks we face? These are the questions that keep researchers like Dr. Erlab and Professor Bosky awake at night, the nagging doubts that gnaw at the edges of their certainty. Because in the end, the story of Etna's looming collapse is not just a tale of scientific intrigue and geological detective work. It is a stark reminder of the awesome and terrifying power of the planet we inhabit, and the precarious nature of our place upon it. This is Earth Attacks, where we expose the hidden planetary systems that governments do not want you to understand. Subscribe to discover the geological connections mainstream science overlooks, because sometimes the greatest disasters announce themselves not with a bang, but with a whisper. And right now, Etna's whispers are getting louder by the day.